Of all the casting process, except for maybe die casting, it's going to give you your tighter tolerances, better finishes, and more detail.
Lamothermic makes investment castings. Is investment casting better than machining? You bet. We can make your parts cheaper and quicker than you can machining them out of our stock.
Investment casting is much more precise. We can hold plus or minus 5 thousandths per inch. We can handle from fractional ounces up to about 60 pounds.
And we can pour a variety of different alloys.
Your carbon steels, your alloy steels, your stainless steels, precipitating hardening steels, cobalt-based, nickel-based.
So investment castings, you can get almost a near net shape part. That means as little machining as possible. Some people choose investment casting because the finish is exactly what they need.
We have a lot of in-house capability where we don't have to send it out. It saves on cost, and it also reduces lead times.
If you don't want to spend the money to tool up on a pattern, we can 3D print your pattern for you to run prototypes.
Quantity, we can handle all quantities. We get from somebody to order 5 or 10 parts to where we're making 20,000 parts a day for surgical instruments.
We've been perfecting our processes since 1976, but really what makes us tick is our people. We have some of the best people you will ever find. This is where it all starts. This is a wax pattern made in our injection molding machine. All investment casting processes start with a wax pattern. So these tools are fully automated. The platens will close, the wax will inject, the cores will pull, and it'll eject the part into the water for the operator to inspect. The water stops from the blow. If you drop this on the ground, it'll shatter. Yes, we design all of our tooling. The tooling is done by our engineers to optimize the way the tool runs. If we're making a part on the automatic machines, we can probably make parts up to about 25, 30 pounds when they end up in metal.
Hey Garrett, one more thing we should mention is that with automatic tooling, we can offer better return on investment on higher volume runs. Automatic tooling allows us to not tie the operation of these machines to the operator. With the machine handling the volume of work, it allows us to produce at a higher rate.
And it'll run parts all throughout the shift. All the operator has to do is simply inspect the parts. The great part of investment casting tooling is the tooling doesn't wear. All that's being shot into it is wax. So the tooling will live for conceivably forever. If you're going to start making several hundreds of parts, you typically want to invest in a tool. You can do 2 different metals with the same tooling too. The changing of the metals doesn't have to do with the tooling. This is our spruing area where we take the wax assemblies and we attach them to the tree. So what you can see here is the parts that are being attached on via sticky wax. That's the runner where the metal is going to be delivered to the parts. The number of parts that we can fit on a runner directly affects the cost of the part. If we can get lots of parts, say 60, 70, 80 to 100 parts on the tree, that means your piece price is going down. Every wax pattern that we make needs a ceramic shell in order to accept the metal. Here's where we make the ceramic shell. This is our automated dipping room.
Hi, I'm Matt and I'm going to be making your shells. This is the robot and the producer system, basically what dips all the shells.
What Matt is doing here, he's loading up the robot. He's taking the patterns that are assembled here, loading them onto a cluster, and the robot inside the cell will pick it up and dip it into the various tanks.
Over here we have the prime tank. It's basically the face coat of the shells. And then on the other side we have a backup tank which builds the strength of the shell.
The first coat it's going to be putting on is called the face coat. That'll capture all the detail, and then it'll bring it into the rainfall sander here. This is fully automated. This will run day and night with only one operator attending it as opposed to hand dipping. So this is our conveyor system where the shells dry in between coats. Our engineers specify part programs for them to use. Typically our average dry time around 3 hours, 4 hours. The shells will go up to the roof line. When it peaks at 49.5 feet, and the shells come back down the other side to dry. You'll notice that some are white, some are gray. The reality is that each one has its own special formula. Depends on the part geometry, the weight of the part, and the metal that's being poured into it. And then Shelly waits for the next assignment. Shelly knows the next assignment because it's all programmed in. After she places this, she's going to go to the next programmed cluster, pick that one up, and keep going. Let me go show you where we melt out the wax.
This is our autoclave / boiler clave where we put the trees in to remove wax.
The wax will melt out and the metal will be poured in. Behind me is our foundry. This is the heart of the business.
They're highly trained, they have a lot of experience, and they love doing what they do.
It's a tough job. These guys do it really well. So after the parts are poured, they have the ceramic shell on them that need to be taken off. They get vibrated in our knockoff machine and then put into our spinner hanger where there's 2 blast wheels that blast stainless steel shot at the parts, cleaning the ceramic off of the parts. The next thing is to take the parts off of the trees. We do that via an abrasive cutting wheel. This is our finishing department. After parts are cut off from the runner, they're moved into this department to do all the final post-processing. Parts are put into our wheelabrator systems to remove the ceramic. We do gate grinding here. We also do sandblasting and inspection on all of our parts. So here's a door handle for a hospital. These parts that I'm pointing to are gates. That's where the metal enters the mold. They're not part of the part and they need to be removed. So these machines along the back wall here are automatic grinders. They have rotary tables. The great thing about these machines is they can run really high volume product over and over and over again very repetitively. A lot of people ask us about cores. So here's an interesting part that we do that has cores. We're able to cast a hole in it. This is a hole here. The wax tooling has cores that we pull out. We can do blind holes, through holes, you name it. 2 cores that get split out to make this center section. One here, one that gets pulled out, and then one that creates this pocket here. This is an industrial door hinge. It goes on the bottom of the door and it swings open. So this is a shackle for the sailboat that we make. This is a piece to a movie projector. We make a couple of different sizes. Here's an example of a part that we make. We make one flavor in bronze and another in stainless, and we also machine it in-house. Several types of parts in the as-cast condition are too hard to machine, so what we do is we heat treat them. We do that here with our vacuum furnace.
And then our stainlesses, like our 300 series, annealing is required. It's because of generally for corrosion resistance.
You've heard of lights out manufacturing. This is lights out testing. Welcome to our NDT testing room. Sometimes in our industry, castings can have surface and subsurface discontinuities. So the only way to find that would be to either put it on magnetic particle inspection machine, which we have here, or with our fluorescent penetrant inspection, which we see here. And both of these methods are considered to be non-destructive testing. Magnetic inspection, we put the part in the coil, bathe it with our bath and fluorescent particle, put the amperage through it, mag it, and then we check it under the black line. And we make sure your parts have no problem. We also do radiographic inspection. We take the parts, we x-ray them, we process the film to make sure there are no internal discontinuities. So let's say we want to check the mechanical capabilities of the parts. This is where we use our Starrett tensile tester.
People often ask how we keep porosity out of our parts. We use computer simulation to simulate everything on the foundry floor before we even go ahead and build your tool.
Here's a great investment cast part. The thing is, customer made a lot of changes. The good news is it didn't cost the client a lot of money. Why? Because we were using solidification software. The solidification software points us in the right direction. So whether or not we have enough feeding into the part, whether it's the gate size, the temperature of the mold, temperature of the metal, we can adjust all those on the fly until we get a sound casting. Because you don't pay for the tooling until it's just right.
In order for us to make our deadlines, the tools, the machines have to be in tip-top shape, and that's where I come in. And if they go down, I'm going to work as hard as I can to get them back up again. I'm Jacob Yunt. I'm the in-house toolmaker here at Lamothermic. I love what I do, so it's great. I love working here.
If our employees see something on the floor that can be improved, they're not afraid to speak up. The goal is to save time and money on your investment casting.